In this video, as we work through adding, subtracting, and multiplying polynomials, we're going to look at some special product patterns that can help us save time. Now, we've seen a couple of these patterns before, such as the sum and difference pattern and the square of a binomial pattern. And both of them still apply even when my polynomials aren't necessarily quadratic in nature. So the first example, if I have a plus b times a minus b, that product will be a squared minus b squared. For instance, x plus 4 times x minus 4 can quickly be multiplied together and will turn into x squared minus 16. You can think of it as the difference of squares factoring pattern, just in the other direction. Here I have the factors and I'm looking for a product, as opposed to going from product to factors. The square of a binomial pattern is what we learned early in the year, and I talked about Mr. LeQuay being my teacher, always taught us how to do this. To square a binomial, you square the first term, multiply the two terms together, double it, then square the second term. For example, if I want to square y plus 3, I square the first term, multiply the two together and double it, and then square the second term. And this still applies even when I've got things that aren't necessarily quadratic in nature, such as this, 3z squared minus 5 squared. Well, same rules apply. Square the first term, which would be 9z to the fourth in this case. Multiply the two together, it'll be negative 15z squared. Double it, negative 30z squared. This is a z in case you're wondering. And square the second term, that will be plus 25 at the end. So that's sum and difference pattern and square of binomial pattern. And I'll put them to work for a couple of more examples. So here there's a sum and difference pattern, same terms, one's a sum, one's a difference. Go ahead and square the first term, x to the fourth, and square the second term, we got 100. Here's the square of a binomial. I start by squaring the first term, that's going to be 64x to the sixth. Key there is x to the sixth, not the ninth, because it's x cubed squared, power of a power property and multiply exponents. Then I multiply the two together and double it. Negative 16 doubled would be negative 32. X cubed y squared. And finally square the second term. That's going to turn into plus 4y to the fourth. Now the other pattern that I see here is the cube of a binomial pattern. So I have a binomial, two terms. I had the square of a binomial pattern, now it's the cube of a binomial. So a couple things about this pattern. It works for both sums and differences. And the terms are basically the same. It's just that if it's a sum, all my terms are positive. If it's a difference, my terms alternate from going positive to negative to positive to negative. So the key here is to identify a and b. What are the two numbers I've got first and second? As I cube my binomial, according to the pattern, the first term is the cube of a. So the cube of the first term. Well, using this example, I cube x and I write x cubed. The next term is 3 times a squared, the first term, times b, the second term. Well, working my way through that one, that'd be 3 times x squared times 2. Well, 3 times 2 is 6, so this must be 6x squared as the first term. Then I have 3 again times a, the first term, times b, the second term, squared. So that'd be 3x times 2 squared. Well, 2 squared happens to be 4, and 4 times the 3 that was there already will be 12. So how about plus 12x? The final term is b cubed, so the second number or factor, whatever it is, cubed. 2 cubed happens to be 8. I'll put a plus 8 at the end there, and there would be my product. Now, if that pattern isn't something you're going to remember, you could always take x plus 2 times x plus 2 times x plus 2 and do a whole lot of FOIL and come up with the same answer. Another example with a difference, p minus 3 cubed. The pattern works the same. I start with the cube of the first term, minus 3 times the first term squared, which is p squared, times the second term, which happens to be 3. Don't worry about if the positive or negative. I know that because this is a difference, it will always be minus this next term. So the 3 that's here times the 3 that's here is 9. So how about minus 9p squared? The plus, next term is going to be positive. 3 times the first term, which is p, times the second term squared. So it's 9. 3 squared is 9 times the 3 that's here is 27. So how about plus 27p? And finally, the opposite of b cubed. So 3 cubed is going to be 27. There's our final term. One more example using the cube of a binomial pattern. If I cube 2x plus 3, I start by cubing the first term, which is 8x cubed. And then I take 3 times the first term squared. Well, that's 4x squared. Times 3 is 12x squared. Times the second term is going to be another 3, so that's going to be 36x squared. Then I have plus 3 times a. Well, 3 times 2x is 6x. Times b squared. B squared is 9 in this case. Times the 6x I already had is going to be 54x. And finally, I take b and cube it, and I get 27 at the end. So there would be my product, the cube of a binomial. There you have it.